In this video, let's use the sine rule to find angles within triangles. We've already done a video on using the sine rule to find sides. So the sine rule can also be used to find an angle, but it's actually easier to write it upside down to the formula that we did on the previous one. So previously you noticed that the sides were on the top of the fraction, the numerator, but this time it's flipped. The thing that you're trying to solve, let's have it the top left-hand side. So that means on the left-hand side of the equals, this would be if we're trying to solve for angle A. And the reason for that, as we say here, is because rearranging that formula is going to be much easier if your unknown is in the numerator. So let's do an example. If we're asked to find the size of angle ABC, so just a refresher that when we have three letters, that the angle in question in the corner that we're after is the middle letter of the three. And the way you could work that out is if you start at A and then you move across to ABC, you're essentially drawing A to B and then to C. So you've drawn two lines, and the corner that those two lines make is the angle that you're interested in. So we're trying to find angle B here. Let's think about what else that we've got, what pairs. So we place the unknown angle B in the top left corner of the formula, as we've said, to make rearranging easier. Now, it doesn't matter if we're solving for A and B or C. Let me sort of explain that a little bit more. So angle B is here, and the side opposite that is the 4. So that would be little letter b. And then in this particular triangle, A is labelled, and so therefore the side across from that would be lowercase a. It wouldn't matter if we were trying to solve for C or if the other information that we had was C. So for example, the other side could be this, sine of C on C. And as long as you've got two pairs and we put them equal to each other, the formula will work out. So the next steps that we need to do here, as I've sort of implied already, start looking at the pairs and then substituting them into the formula. So we had the B is what we're trying to find, and so that's why that's still the unknown. The 4 comes from the side opposite angle B, which is little letter b, 4 there. And then the other pair that we have for the A, the angle was 72 and the side length was 6. Rearranging that, what needs to move? That 4 there in the denominator needs to essentially be multiplied up to the other side. We're essentially multiplying both sides by 4, so that cancels it out on the left. And there's our multiply sign here on the right-hand side of the equals. But you could then work that out, or you could, and then get a decimal number, or you can move straight to using inverse sign so that we isolate and make B on its own. And so this would be the most exact thing to type into your calculator for the highest level of accuracy, making sure you're in degrees, and then that would round to 39.35, and the units are degrees. I thought I'd do this extra bit to now summarize the cosine and the sine rule, or the cos and the sine rule, and how do you decide which one to use at any point in time. If you're doing questions in a textbook and you're in the section on cosine and it says, oh, use the cosine rule to find a side or use it to find an angle, well, that's easy. But when you start to come into worded problems and you have to draw the diagram and it doesn't tell you if you use cosine or sine, you have to work it out. How do you decide? So my suggestion would be to write these 4 examples on your page and then let me summarize them for you. So we're trying to find a side or an angle. That's the two things we're trying to find. So let's look at A and B, the ones on the left-hand side there. What are they trying to find? Where's the unknown? It's X. And where in a triangle is that each time there? That is on it's a side. So these two examples are trying to find sides. So I'm going to write that. And then you have to decide, are they pairs? Because we've just done some sine rule here, and those act in pairs. Remember, there's an angle that's paired with the side across from it. And then cosine often involves an included angle and sides. So let's have a look. A here. So we've got X across from angle 39. And there's another pair there as well. There's angle 33 across from 6. So this one is going to be the sine rule, solving for a side. So that's where you put that at the top of the fraction. Let me write that out for you. If we were to label this, say, A here and B, then the formula you would use for this one would be A on sine A is equal to B on sine capital B. Then the next one's going to be cos. And let's see why. We've got our x here, but what else have we got? We've got the 99, and that is an included angle between those other two sides. So this is the cosine rule, solving for a side. And this is quite a long one to write out. Again, we can label it, so we could call this little a and the side over there capital A, and call the other two sides B and C. Doesn't matter which one is which. And the formula for this would be a squared is equal to b squared plus c squared minus 2bc cos of capital A. And so that matches this one. What about the other two? What are we solving for here if we call these C and D? Well, you can see a theta in the corner here, and in D, we've got a capital C. That's the thing we're solving for. So, which one's sine rule? Which one's cosine rule? Let's start with C. What have we got? We've got an 8, we've got a 15, and an 11, and they are all sides. And cosine rule is the one to use when you have 3 sides. Maybe I'll write that. 3 sides equals cosine. And that's the one with a fraction for cosine, because we're solving for an angle. So this time round, I'll label them as well. I'll call that angle A, which means this is side A. Again, doesn't matter which is B and C. So the formula for this is cosine of A is equal to, big fraction, B squared plus C squared, and now the subtract for the side opposite the angle, so A squared over 2BC. So that is for C. That's the formula to use. And then D is a sine rule. So let's look at our pairs here. We've got a pair here, and the 28 and 8 are a pair. I'm going to use the lettering there. We've got angle C, and therefore this is side C, angle B, and side B. So I'm going to use a C and a B this time around, and that's really good because it just shows you the different one that we can use. We are solving for a sine of an angle, so that's what we put at the top of our fraction on the left-hand side, over sine C is equal to sine capital letter B over B there. So this was the sine rule for an angle. I hope that's a good summary for the 4 different scenarios that you can get. It'll only be one of these 4, so you have to work out which one each time. If you're in Year 11 General, these are some of the questions to do now. Thanks for joining me.